Okay, so for this question, right, it is a pure question of integration where you are supposed to get the equation of the curve. So that means your job is to find the expression for y starting from the second derivative. So this question starts from the second derivative and you are supposed to integrate slowly backwards to get back the expression for y. So do remember the sequence first. So usually our sequence of differentiation will be something like this. So you differentiate one, then you differentiate twice. Okay, so if you differentiate twice to get the second derivative, in order to get back the original expression, you will have to integrate twice. So that will be our basic logic. However, the complication again comes upon each integration. So each integration will generate one unknown. So if you're going to integrate twice, there will be two unknown. So there must be sufficient information for you to find the two unknown. So the challenge is also getting the unknown correctly. Okay, this question starts from the second derivative, and the second derivative is in exponential function. So basically, we'll be using a lot on this formula. Integrate e ax plus b will be equal to 1 over a e ax plus b. So we'll be using this basic formula a lot. Okay, so it's a 7 marks question. However, it's not very difficult. So you just have to execute each integration carefully. So it'll be good if, let's say, you write out the formula. Okay, so I have this expectation that I will have two unknown to solve. So I'll be looking around for two pieces of information. So the first question, the first information is the curve intersect the y-axis at here. So this will already generate a piece of information when x is equal to 0, y is equal to 5. And it also mentioned about a gradient 3 at P. So having a gradient 3 at P means that when x is equal to 0, dy dx is equal to 3. So when we say gradient, it's represented by dy dx. So this will be the two pieces of information that I will subsequently need to get my unknown. So that should be the first awareness. But there will be students who forget that each time you integrate, you need the unknown. Okay, or there will be students who know that they need the unknown, but then they couldn't sit up that two information to find. So the integration can be rather incomplete. Okay, so let's think about the first layer of integration first. So I will be integrating my second derivative to get my dy dx. So now my focus is to get my dy dx. So if you look at the formula, okay, so in this case, right, here, a is equal to -1. And then in this case, a is equal to 2. So according to the formula. So I just have to integrate, apply the formula, and then get a k. So at this stage, right, I'm going to find my constant for the gradient. So the constant that I'm looking for is for dy dx. So I'll be using this piece of information. So you need to put in the value carefully. E to the power of 0 is not going to give you 0. So some people will instinctively thought of e to the power of 0 is 0, and then they mess up the constant. So e to the power of 0 is 1. So from here, you do it carefully, you'll get your k. So your dy dx is completed. And because you need your dy dx to continue one more level of integration, do make sure that there is no careless first. Then you move on. So when I move on, I will integrate one more time. And the same thing happened. In my a here is a -1. Okay, my a is a 2. So I'm applying the same formula. So integrating a constant will just be a 2x. So here I already gotten what the question wants, except that I will have another unknown. So label this unknown differently from the previous one. So some people will do a C1, C2, K1, K2. So in this case, I'm using K and C. So put in the coordinate that has been given previously and solve carefully, you will be able to get the final unknown and then your equation of the graph curve will be solved totally. So I would say this one is not a very difficult question to score. If you're not prone to careless, if you're very, very careful, the whole question will work out very well.